Hey everybody, so we are going to be continuing the trend that I started last summer, which is reviewing books from the knowledge graph and semantic space. And the reason I do this is because so many of you ask me what books I would recommend if you are just getting started or if you want to learn more information about semantics. So that is what we're going to be doing. And today we are going to be reviewing that book. And with all of these reviews, I always give away my review copy to someone in the audience. So if you are interested in that, make sure you check the description down below for more details. All right, so with that, let's go get started.
I've been working in the area of ontologies and semantic technology since around 2005. So it's almost 20 years now. Back in the era where we had not even OWL, I had that dumb Lenoil. I remember when I was doing my master thesis. And definitely before the era of machine learning, big data, and LLMs, as we have them now, and they are very in vogue.
Taking over, or it seems like it with all the hype.
Yes, it's a great discussion topic, actually. And indeed, so I've been working mostly as an ontologist and as a semantic technology solution architect. In many projects, especially in relation with academia, so a lot of research projects for proof of concepts and for, also I did my PhD in the topic in the industry. But yeah, for the last, since 2016, I'm in a company called Taxonomies in the Netherlands, where we have, where my team leads, develops a knowledge graph about the HR and recruitment domain. So some further context, Taxonomies builds software for semantic analysis of CVs and vacancies and matching them together. And in doing that, we utilize a combination of course, machine learning, deep learning techniques, along with good old-fashioned symbolic AI.
Oh, there we go. Symbolic AI. A lot of folks don't know what that is. So can you explain a little bit about that?
Sure. Symbolic AI is an approach to AI, rather naive as it seems now, but back like 30 years ago, it was all the rage, that suggests that we are able to represent and manipulate human knowledge and reason with it by means of symbols, right? Not by means of mathematics. So the idea is that we define concepts, we define entities and rules about our language and about the concepts that exist in the world. One of the first manifestations of that were back in the 80s, the so-called expert systems that coding a lot of rules by domain experts about how machines should reason, for example, about medical aspects and other things. And then in the late 90s, this took the form of semantic networks, of ontologies, taxonomies, etc. So it's a general approach of organizing human knowledge in a symbolic way, not in a mathematical way.
But let's focus on what you cover in the book first. You're talking about semantic modeling, and you just mentioned a few words here, like ontology, knowledge graph. Are those all representations of semantic modeling? What is that?
Great question. So one of the challenges I faced while reading the book was in which kind of artifacts should I focus? Should I talk about knowledge graphs? Should I talk about ontologies? And then I realized that in practice, all data practitioners and all data modelers, to some extent, do semantic modeling in their work, no matter how they call it. So the definition I gave in the book is rather an umbrella term that suggests that and says that semantic modeling is the practice and the action of developing representations and descriptions of data whose purpose is to convey the meaning of data in an accurate, explicit, and commonly understood way. So it's not about the actual content and the actual structure of the model. More, of course, we're talking about symbolic models here, but it's rather the purpose. So even people and practitioners who develop a database schema using entity relationship modeling, that usually is what you get taught in your undergraduate computer science, this is a kind of semantic modeling, right? When you build a simple metadata schema to describe your articles or your data, or a controlled vocabulary, that's also an artifact that can be considered a semantic model. artifacts have different capabilities and different levels of expressivity and of explicitness. But you can consider this as a continuum of semantic models. So it's a pretty broad term. What is not a semantic model is, for example, an embedding. Don't consider this, although you can say that it has some symbolic and hidden semantics, it does have, but because the meaning is not explicit and not easily understandable to a human, in that sense, I didn't put it in the scope of semantic data modeling.
I mean, that's a good distinction too to keep in mind, right? Like there's, and I've talked to a lot of folks that they kind of just anything that even remotely is impacted by the semantic modeling is then kind of sucked up into its semantic modeling or its semantics. But I think that's a good point that you've made here. And you even touched on other things in the book with the phenomenon of like things that are not explicit, things that are not human understood. Like it's a symbolic thing, but just for the machines to understand, which are important, right? Like these embeddings are things that maybe the human mind cannot, get at effectively. We're all very smart humans, right? So we can sit down and if we had enough time and enough compute power, i.e. brain power and snacks next to you to get through everything in your analytics, could you find the shortest path between one thing and another? Yes. Could you do that on a billion node graph in a few short seconds? No. That's why the computers do their thing and then the humans do their thing, and the humans have to understand how to then formulate that, which is semantic modeling, right? So that then, downstream applications can use it. So I like how you very, it's not a clear line because of course there's like some fuzziness between the two, but it's a better line than I've heard others say. So that's a plus.
That's the main way. Of course, you will see the same thing being modeled differently even in the same model sometimes. I've seen, for example, schema.org having a property in a relation for the same matrix, for the same characteristic.
Well, and I think that's why it sometimes gets so confusing, right? Like another one that you touch on in the book is an instance or a class.
That's my favorite.
These are the things, right? Like I think this is why, and I know you and I were talking about this a little bit offline as well when we were chatting about this interview on the book is, it's so different. And this is why books like yours are so important, some of the concepts, but then putting it into practice, that's where it gets so confusing for folks that are, not formally trained, which is like most of us on this semantic stuff. That's why books like yours are so important, I think, is not just to get the right answer, but to know that there isn't always a right answer. Right?
Yeah, for me, one of the reasons and one of the struggles I had when I was writing the book, especially when I was writing the first chapter, which was about what elements exist in a semantic model, was to reconcile the different terminology that we use, because different communities within the data space use totally terminology, right? Mention class. Class has at least 3 usages. One in the semantic web, like in OWL and RDF, where we know that is a type of things. Then we have class, of course, in software engineering, which has methods also, and in semantic web, you don't want that. And then you have the classes in classification in machine learning, where practically a class can be a category. And then even within the particular communities, you have additional things. So, for example, in Protégé, you have the terminology about object properties versus data type properties. So they call the relation properties. So yeah, it's hard, and I try to do not a complete work, but rather to reconcile things. Also, there was this natural language community, WordNet, for example, where they use synsets and they use different things. So yeah, it starts from us. It starts from us, the modelers, to try to not so much define, how to say, the perfect definition for each element. There's not a single name, but rather to be aware of the mappings. That's especially important when we interact with other people that know other frameworks, or when we get to ingest data or other knowledge models that have been used with other languages in mind.
Yeah, absolutely. And I love that because there's so much like uh, every job I've ever had, I feel like I get on and I start talking about this semantic stuff, and then you have to do the data dance. Right? Like, oh, what do you call this thing? Well, this is a customer class. Okay, what's a customer here? Like, okay, and then you realize we
Customer,
have 20 different types of versions of that.
not straightforward what is a customer. And the thing is that whether we want it or not, and it's okay, as modelers, we embed a lot of assumptions and biases within our models.
Mm-hmm.
It's okay, but we need to be aware of that. And
Yes.
the thing is, a myth that I always try to fight is that just because you represent something in OWL, in RDF, or even in symbolic way, doesn't mean that it magically becomes true or magically becomes
Yes.
acceptable, right? So
Yep.
in the same way that you can have garbage in, garbage out in a machine learning model, the same thing applies in for semantic models and for knowledge graphs.
Absolutely. And it's really important. And this is why I do highlight a lot, and a lot of the data modeling tools that are out there, even Protege is love it or hate it. There you have to be able to see the model, because you start to realize, oh, that's not right. Oh, that's not how those two things should relate to each other, right? And you start to see that. Now, can you do that at scale? No, but it's good to start. And I think it's good to help people get their model started, right? Because to your point, it's very use case based. It's your situation that you're trying to model, and sometimes you just don't know it until you start to model it out and see, oh wait, I thought that's how it related, but now that I see how that connects to other things, it's not the best way to model that. I've done that so many times.
Yes, the tools themselves, I haven't used too many tools, but the tools themselves can contain bias,
Yes.
modeling bias. So Protege is a great example. The way Protege is the UI, it practically allows you to visualize as a hierarchy only the classes.
Mm-hmm.
If you create a SCOS hierarchy between concepts, which are not necessarily a subclass,
Mm-hmm. Mm-hmm.
you don't see it as a hierarchy.
Mm-hmm.
That's okay. But the thing is, and this is my suspicion, I haven't verified, but my suspicion is that when a modeler thinks of a hierarchical relation, their first instinct using Protege is to go and put it in the hierarchy.
Mm-hmm.
The result is that the hierarchy of classes and subclasses ends up containing not only classes but also individuals.
Yep.
Not only the subclass relation but also the part of relation, which is not even transitive and doesn't have the logical implication that we know about classes and subclasses, and or just related things, related, which are okay in other taxonomies but not in a subclass hierarchy.
Yeah.
I do think I don't have a formal study for that, but I think that's a bias from inhibited by the tool, and also from the guide itself. So I mentioned in the book that when you read the first Protege tutorial, it tells you any concept is a class, which is so wrong.
Well, and there's the other thing with Protege is because it is a widely adopted tool and it's open, a lot of people use it for a lot of different reasons, right? Like I have a whole video talking about how, so many folks in the taxonomy space don't use Protege because they think it's just an ontology. But if you look at it like you're saying, it's a hierarchy if you really just want to use it as a taxonomy tool. Like I wouldn't recommend doing that, of course. But if you needed something just, out of Excel to create something that's just hierarchical and it's a taxonomy where the nodes in the ontology are your classes and they're really just your taxonomy terms. They are a global representation of the cat. Does that mean it's the cat that like lives in my neighborhood? No, that's an instance. That's the instance of the cat, right? But it depends. I mean, that's not ontology for sure, right? But I think that because that tool is versatile on purpose because it's open and just used by the research community in a lot of other communities. You can use a lot of different things, but that also, I think to your point, doesn't do a lot of favors for the folks that are trying to use it for ontology, because you kind of fall into that rabbit hole of, oh, I'll just put it in as a hierarchy, and then you don't, there's those hidden relationships in a hierarchy, right? Like you can make them explicit and say, is as your relationship between, a parent and a child, if that's the relationship you're trying to represent. But then you're getting into instances and you're mixing the class and the instances, right? And then there's all those like, why are these two things related? They're just in a hierarchy, right?
If you go to there is a Nancy, right, a Nancy standard about taxonomy.
Mm-hmm.
But if you go to traditional taxonomies that do not know anything about RDF and know not even scores,
Yes.
they will tell you that they use that. And it says explicitly that standard that a taxonomy contains three types of relations. The relation broader, narrower, like the one, so for example, animal, mammal, assuming that these are classes can be considered as a subclass relation. The type of instance of relation, so like European country, and then you have under it Greece, Netherlands, etc. This is actually an instance of relation, also a part of relation. So you can have something like how to say
Like
Europe,
a vehicle has an engine.
Northern Europe, Denmark. This is a part of relation, which actually is about location. So a taxonomy, according to that standard, blends three relations into one, which I think successfully SCOS, the simple knowledge validation system, models as broader, narrower, and that's okay. The problem starts when you consider this as a class hierarchy, which happens in OWL. A class hierarchy can be easily moved to a SCOS hierarchy, broader, narrower. In first, no, you have to dig into the relations and see what's going on.
Oh, I 100% agree. Like when you get into,
you get funny or bad inferences.
Yeah,
because about inferencing.
So true. And in the standards, see also. That's your ontology. Like, not saying that's your ontology, meaning that little tag is a world of relationship. Because they're not explicit, right? And then, that's okay. Like taxonomies do their thing, ontologies do their thing, like it's okay. But I think that's why, when we talk about semantic modeling, taxonomies are also semantic, right? And so you could have people picking up on these things. I'm glad that you go over so much of that in the book, because I think that's a big reason that I think a lot of folks should pick it up. Not just because I love the way that you write in it, like you're very you're very easy to understand, right? Like you don't put on you don't presume a lot of things that people have like an understanding of ahead of time, right? Like you have some basic things like that, but you do a thorough job of explaining things, which I really do appreciate, and you do it in an accessible way, which again, I have a whole channel about that, so I really do appreciate that.
That is our job. Our job is not to use RDF. Our job is not to use Neo4j. These are our tools. Our job is to make data and information explicit and interoperable as much as possible.
And translate it for the use case, right? Which is an important part of what you talk about. It's not just, and there's so many folks that they just want to model the world to model it, and they get experience doing that. But if you don't know why, like, okay, I'm going to be using it in LLM, then I need to make very distinct decisions when I'm doing my modeling, or versus if I'm building this out for an analytics like Power BI or something. That's a very different use case. So I think that like those modeling decisions you really cover really well. And I think that's like my favorite part of the book, because there were so many times I'm reading through that I'm like, yeah, that's how I would have done it. So I do.
It's not about how to say, I don't claim to be that these are the magical solution. And in the case of dilemma, it's more about I'm not telling you do that or that. It's what information, I'm talking about what information you need to gather and how to, because it's still an investigation process on taking a decision,
Yes.
right?
Decision
So, and
making is key.
what works in my current, what I did for a specific project will not necessarily work in your project, in your application.
Absolutely. Absolutely.
Let's say that you want to create a global semantic web, as it's called. There's no way that this global model will contain a single truth.
Very
Multiple
true.
truths, definitely. And unfortunately, the semantic web community and the languages do not, how to say, it is possible to represent multiple truths with OL and
Yeah.
RD, but they don't actively encourage it.
Yeah, that's a very, and I mean, even it goes back to the naming. Is it a statement? Is it a fact? Is it like what is it? What is a triple, right? There's a lot of different words for what that thing is. And yeah, I mean, you can't really say it's a fact because depends on who you ask, right? There are certain facts, that we could say, like, well, the sun is a burning ball of stuff up in space, but depends on when you were around and alive, right? There was a point in time people didn't think that, right? So us as humans are constantly evolving and changing and understanding better about our world and our each
Exactly.
other. And
Exactly. And the more abstract are our domains, like it's much easier. Let's say we've seen a lot of linked data talking about people, organizations, locations. Yes, these are concrete entities and they are not fully easy, but relatively easy to understand what they're about and model. When we start going into more abstract domains, like for example, in my domain about occupations and skill, it's
yeah,
often hard to decide, for example, whether two professions, whether two job titles are the same or not. And what constitutes, for example, I don't know, even an ontologist. If you ask people, what is an ontologist and what are
oh,
the skills that they need to have?
oh, it's always different.
Single definition that you would put in a global model. An
Yeah.
ontologist in the US might be different than an ontologist in Europe.
An ontologist could be different even in the same organization.
Exactly.
Right.
Right?
Yeah.
And the struggle as a modeler, you can call yourself ontologist, but the term I use is modeler, semantic modeler, as a broad term, is to decide what what is useful in the end, what distinctions, what semantic distinctions are useful to represent, and what you can keep as they are.
I really did appreciate that you walked through how to make decisions because so many times people are like, well, should I model it this way or model it that way? And I hate being that person that say, well, it depends, right? But it's so often, it depends. And then I don't have
Obviously.
the time because I don't know their use case as well as they do. And, usually they're just sending me a message, through LinkedIn or my YouTube asking, well, like, can you tell me? And it's like, well, you got to walk through that decision-making process. And now I'm super excited because now I can just say, go read Panos' book.
For some of the decisions, yes, not for
Yeah,
all,
I mean, it's,
but
well, that
yeah,
just means you have to do a version 2, right? Like you have to do a new edition.
yeah, probably.
Probably, or do like a compendium that kind of like goes through a little bit more of that. But I really do appreciate all that you've done here. So yeah, as we do with all of these videos, there's going to be one free giveaway for the book. So if you're interested in that, talking to the audience here, description box will have more details on that. And I want to thank you, Panos, for joining me today. It's been really fun.
Interesting. Thank you very much. It was great talking to you.